so much for coming. This is such a beautiful sight to see. Students in distress. Hopefully the picture is better than that. Thank you so much for coming. We truly appreciate the fact that you take the time to come to these events, to hear your fellow students give presentations, and just be part of the team. We have two presentations today. Grayson Blanks worked with Dr. Gundry, and he is our first presenter.
Is the lighting okay? Can everyone see? Okay, so my presentation is going to be about the evaluation of a parallelized pseudo-random number generator test suite. A lot of words. What does it all mean? What is a pseudo-random number generator? What is it used for? A pseudo-random number generator essentially allows computers to incorporate randomness into them, which is basically a hard feat in its own right because computers are deterministic machines. So some uses for it, probably the biggest one you guys might all know is video games. You know, you have drop rates or random events happen. Some simulations use them. The Monte Carlo's probably the biggest one. Basically, there's variables that you can't account for, or they're non-deterministic, so the best way to account for that is randomness. And then the biggest one's going to be cryptography. So you have the entropy and random number generators that are used to help create cryptographic keys, either public or private. You also have TLS or SSL. So when you connect to your bank, you might be using one of these protocols, which is built into the browser. It uses a random number to help specify, hey, this is the session I'm using. Only two people are having a conversation over this network, and it's secure. And the key point is that we want to make sure that is these pseudo-random number generator strong? Is it cryptographically secure? If you're always producing one, that's going to be a pretty predictable random number generator, or 4, as the example is. So an example of a fair random number generator might be a die. And this slide really is just to show you guys that it's important to get these pseudo-random number generators right the first time in order to make it strong. If it's weak, then security is lost, or people might be able to exploit it if they know how the random generator is going to be random, essentially. So jumping right into it, this isn't the first test suite. You have Die Hard from 1995, which is actually it's a fork from Die Harder. We have the statistical test suite from NIST, which is another pretty good one. The one that I'm using is a fork off of Die Harder, which was produced by Robert Brown in 2013. So a pseudo-random number generator test suite essentially works this way. You have the algorithm, and it takes in a seed. The seed is just a number, and it will spit out another number, and you can do this as many times as you want. It's unlimited. You can do it forever. And then the output, so we grab a section of those numbers and we put it into the test suite. And the test suite, to boil things down, says, hey, it's random, it looks random, or hey, it's not random, I can predict it now. So where do I fit into all this? Dr. Gundry took on he had a grad student, Zhang, and he took Die Harder, that fork that I was talking about earlier, and implemented a multi-threaded version of it, both with pthread and OMP, and did some preliminary testing. And I kind of just picked it up from where he left off. So I'm testing I'm doing a code review. There's a lot of dead code, or there's some cleanup that needed to be happening, or just formatting was a little bit off. Collected some data from the code that he produced, tested the code further, so it's no longer preliminary, and then analyzed the data with graphs. So this is just kind of an overview of what I did. So you have the test suite. The two we're going to really be looking at is the original Die Harder, and then the new Die Harder, which is the one that Zhang helped produce, and then I kind of helped fix, clean up, and work on. And it takes in a PRNG, so there's a bunch of them. There's a whole suite of them. The two that we used was the Mersenne Twister, which is a pretty popular PRNG. You have Taos, which is, it's a really fast one. I can't speak if it's cryptographically secure or not, but it's a fast one. We use a p-multiply, which basically just increases the numbers that you're going to be generating, or the samples, and it allows you to speak statistically how confident you are if it's cryptographically secure or not. And then the schedulers. So these last two I just want to point out are specific to the new diehard, not the old one. So the original one was serial. It didn't have any kind of scheduler. The new one now has a serial version, of POSIX threads or p-threads, OMP with both dynamic and static schedulers. So this is, once you run all those variables into the test suite, I have a bash script that changes these variables, produces a log file of all of the information, the amount of time it took, what test was ran, and then we use that to plug in all these graphs that I'll be showing in a second. The environments were, Zhang's was an Amazon C3 X large. Basically, what you need to know is that my results aren't going to be exactly the same as Zhang's. We have a little bit newer hardware, a little bit faster. So we used one that was a little bit faster than that. And then we also used Chameleon, which had the most significant part is the 48 cores, which we wanted to test and see, how far does this parallelism really go, where you have, you don't have diminishing returns. So one of the first graphs is the AWS, the new versus the old. So the green dot is the old, and we kind of saw a minor improvement. It's still pretty linear in nature, so Zhang kind of made some optimizations that are kind of faster. And I'd just like to point out that these are minutes, not seconds, so these tests take a while. The AWS took close to, all the testing took about 250 hours, equates to a week and a half. And then we have the number of threads. So because this is serial, there's only one, this should be the number of p-multiply, not the threads. So there's only one thread, and then this is the p-multiply. And I said earlier that those p-multiplies increase how cryptographically secure it is. And just so that you know that these points aren't like one finite data point. It's actually 5 tests. It's hard to see, but there's 5 tests for every 1 point. They're so tightly clustered that they look like 1 point. So that's good. That means that our data seems to be running close, like tightly together. And so now that we're going to show the number of threads, and the colors are represented by the p-multiply. So you have the p-multiply, like it makes sense, right? You're doing more testing, so it takes longer. It takes almost an hour, almost 2 hours. And then you see a significant decrease in terms of every p-multiply on a single thread. And then you can kind of naively say that, if you have double the amount of threads, it's going to be about half the time. But then you kind of get a taper off at the end in terms of, diminishing returns and the resource management in order to handle all those threads. So then we were showing the difference. We wanted to look at the difference between the POSIX threads and the static scheduler. And with a single thread, there's not really much you can do. There's only so many ways to schedule a single thread, right? There's not many resources. But when then you include the resources, you kind of get we noticed with static, it was a little bit slower. So, I mean, again, this is the difference in minutes between the two. You don't get a significant change in minutes in terms of the first, say, 3. So this is p-multiply 1, the orange is 2, blue's 4, and then 8. And 8 is really where you have a whole bunch, and then you start to see, hey, we're getting a change of 3 minutes, which, again, in a scheme of 2 hours, isn't that much less time. So then we also have the OMP dynamic versus static. And again, on the 1 threads, nothing special there. We see as slow, so there's kind of, you save more time with the static is slower, in comparison to the dynamic as you add the more threads and the more p multiplies. And then, so we did a comparison of Taos and the Mersenne twister. The reason why we picked Taos is because it was the fastest in the suite. So this is from the test suite, and it's saying it's 1,754 kilobytes a second. So that was faster than our twister, which is 1,370. So this kind of provides a sanity check that, hey, is our random number generator within the test suite working correctly? So this is a comparison of the Mersenne twister versus the Taos. And you can consistently see that, Mersenne's twister is, this is negative minutes, so it's performing slower than Taos, which is to be expected, right? We just saw the graph before that it's running faster. And I mean, in the grand scheme of things, that it's the same format, right? So when you start to get to 2 or 3 threads, you kind of see a difference that, it's almost, you're saving time almost. It's almost comparable in terms of the amount of resources you're taking. So that's everything I got for you guys. Any questions? Thank you for listening. Okay.
Thank you, Grayson.
Thank you.
Sure you talk. Weston. There it is. Weston Mitchell is going to give our second presentation. I just got some plates. It seems like we ran out of them. Please get some pizza. We have more. All right. Our next speaker is Weston Mitchell. Weston has a project that was under one of the 495s that I directed. Here's Weston.
All right, my name is Weston Mitchell, and I decided to build a robot for my project. It's called the QuadBot, and I'm going to start off by giving you a little bit of background how I found this. So it all started with Instagram. I know most of you probably have an Instagram. It's really cool when it comes to tech. The tech scene on Instagram is really booming right now. And so I started, following different tech Instagrams, companies that I like Asus, NVIDIA. I started finding developer Instagrams talking about code and different frameworks and stuff. And one of which that I came across was Wevolver. Wevolver is a company dedicated to open source hardware projects, and they showcase a lot of different hardware projects that are both open source and non-open source, but we'll give you information on those. And they have an Instagram. That's how I found them, and so you can check them out. And here are a couple of projects that they have on their website, and they range from robots to drones to motorcycles to many different types of hardware projects. So that's how I found the QuadBot. And the QuadBot is by NGMake, a UK hardware startup that got started by Kickstarter. Their goal was something like 12.5K, and they got like 48,000, so they nailed it. And I can see why, because it's a pretty awesome robotic maker kit that they're trying to, their goal is basically to get robots to the general community. It doesn't matter if you have a background in coding or don't have a background in coding, don't have a background in hardware. They just supply you with the instructions and the means and materials to design and build these robots. So when I got the package, this is what I got. I got an Arduino board, Arduino Leonardo, and 12 servo motors. And then they sent me the 3D design files for the skeleton of the robot. And so I needed access to a 3D printer, and I didn't have one. I do know that SSU does have 3D printers in the library. However, I found a fellow developer in Sebastopol, where I live, that is a member of Chimera Makerspace. And Chimera, if you don't know what a makerspace is, it's basically a community of inventors, thinkers, and craftsmen that have different skill sets come together and work in the same space. So it's actually a really great resource. You can meet a lot of really cool people that have really good skills. So since he was a member and I told him I was building a robot for my senior project, he said, hey, you should come over to Chimera. We got plenty of 3D printers. So I went over there and I checked it out. It was actually really cool. They're very welcoming. So I ended up joining Chimera to use their 3D printers. And this is a photo of me printing one of my parts for the robot. This is the printer bot, and I'm using PLA filament. And I did upwards of about 30 hours of printing to get this done with trial and error. And it was pretty difficult, but it's kind of like riding a bike. Like once you get it down, you're good to go, and you can just get the ball rolling with it. So I ended up having to spend upwards of 30 hours to print all of these parts. Each one of those took about anywhere from 30 minutes to upwards of an hour. It came with the servo motors, the kit did, and the nuts, bolts, and screws, hex spacers. So, basically assembling all this together, the assembly time took about 2 or 3 hours. So once all the 3D printing was done, I was like, sweet, yes, now I can get it assembled and get it running with some code. This is kind of just a layout showing you which servo motors plug into which pin on the Arduino itself. And then once I had it all assembled and ready to go, the fun stuff came, the coding. And here we are. I have some sample code that I had in the Arduino software. The code that runs is essentially C++, but it's compiled into Arduino-based bytecode, I believe. And so Arduino code is essentially C++, but just compiled differently, has a different file extension .ino. And yeah, so this is some of the code that I worked with. And then the end product is this, the FestBot. And I have it here. So, unfortunately, as I was testing and prepping for this presentation last night, the battery died on me. And I went to like 3 or 4 different places today to try and get a new battery. And apparently this battery isn't your run-of-the-mill battery. It's a 3.7 volt, 1200 mAh, or 15C discharge battery. That's, I guess, pretty uncommon. But I will go ahead and give this a whirl. It might have some juice left. There is a little bit more than 3 volts left on the battery, so I will turn it on and see if it wants to come alive. Yeah, it's, it's still just not enough juice to get it going, but you get the idea. But what it can do is it can, curl up like it was initially, stand up, walk. I can make it turn, counterclockwise, counterclockwise, clockwise. I can make it wave at you. I can make it bounce. And that's really cool too. And I call it the FestBot. And the reason is because I want it to be a festive bot. I want it to be interactive. So I'm going to make it dance. I'm going to, program dancing algorithms. I'm going to include the wave in there too, because I think that's super cool how it can wave at people. But what I can show you here, since it didn't come alive for you, is I have a video. Hopefully this will play. There we go. That's it waving there. Yeah, pretty cool, huh? And this is my tech Instagram. So I got the idea of starting my own Instagram based all on my technical experiences. And I think it's just really cool because I've actually come into contact with other developers from around the world. And it's just really awesome. And a lot of these people are cool. And you can, collaborate or network. And yeah, I think it's a really good resource to use. So, I encourage you guys to do the same. Thank you.
Questions?
Yeah, questions.
So this seems like the kind of thing that could be used in like a classroom setting to teach things like 3D printing and maybe some coding and stuff.
Absolutely.
I was wondering how much does something like that cost, and do you think that it would be like viable in maybe a high school or university setting?
Yeah, absolutely. I mean, depending on what the funding is, But for example, this robotic kit I purchased for $350, but that includes the prototype kit and the production kit. So they're actually going to be sending me the production kit. They should have already shipped it actually right now. And so essentially I'm going to have two robots. I'm going to have this prototype one, and then I'm going to have the production one. The production one differs because the Arduino board has, the production Arduino board will have protection against short circuiting. And I would imagine better servos, because the servos were kind of not exactly lined exactly how they should have been, so like the legs were kind of off center. So there's small little intricacies like that, and I'm sure they're gonna do some more stuff to make it more on point. But yeah, I mean, this is totally feasible for the classroom, absolutely. 3D printers go for anywhere from $400 or $500 north of $1,000, probably even more, just depending on what printer you're using. But yeah, I would love to see it in the classroom for sure. Dr. Watts.
Similar question, but how much did you spend to get the film, the thread?
The filament?
Filament, yeah.
Oh, the filament, I actually just got that question essentially. And the filament, a roll of filament, PLA filament is $30. And I believe the ABS filament, which is another type, is also $30 a roll, and that's a rough estimate. I'm sure you could maybe find cheaper, maybe a little more expensive, depending on how much filament comes in the package. Yeah. Any other questions? You back there, Tyler?
How much of a roll did you use for all the printing?
That's a good question. I actually used the filament at Chimera, so they supplied me with the filament. And it's a nonprofit, so I told them I'd buy some more and bring it back and leave it there. Yeah, so $30 and yeah. Go ahead.
Have you considered making your own modifications to it, and outside of software, adding new hardware?
Absolutely. I didn't touch on that base. I actually do plan on designing and developing this much further. I have all the 3D design files, and I can modify those files for pretty much whatever I want. And one thing I do plan on doing is mounting a laser on the top of the shell, hopefully with a servo motor, so then I can make it spin around. But yeah, I mean, I also want to add more LED lights, and you can actually manipulate those lights. So I could do light shows, which would be really cool. I have a Bluetooth module that I didn't mention that I will use to essentially create an iOS application or maybe an Android application to remote control the robot, which is basically my biggest future goals. I want to design my own app on my phone to control the robot. So, yeah. Yeah, thanks.
Thank you.
Yeah, absolutely. Thank you, guys.
So our next event is awards for Wix and the CS Club, and here's Dr. Moore giving awards for the Wix officers.
We had an awesome Wix group this semester who are excellent t-shirt designers among many, many other things. So I just want to recognize this year's officers. So the president was Brooke Borges. The treasurer is Sarah Mosley.
Wait a minute, I'm slower than Roger.
And the events coordinator was Jessica DiVincenzi. Sorry to make y'all come back up. Can we do the whole group?
Yes.
Thank you.
Dr. Watts.
Hi, I'm Dr. Watts, and yes, I am going to present the awards for the Computer Science Club. Would you come up here and just all stand here? So the president of the club this year, Jessica DiVincenzi. The vice president.
I'm going to take a picture. Oh, well, you mean
We'll just do all
together? Okay, excellent.
Jonathan Thompson. There you go. Kevin Considine is the treasurer. Tyler Gearing, events coordinator. The marketing and public relations officer. Didn't know we had one of those. Colin Franceschini. Okay, hang on back.
Okay, ready, go.
It's set up to do,
Oh, it already set up multiple.
yeah, well, it's set up on high speeds.
Now you have many.
That's okay. Yeah.
Thank you so much, the club officers, Wix officers. We really are grateful for the service you provide. It's an essential service to our department. We already have elected officers for the next year, and those of you who remain here, we really love for you to participate in the club events and help the incoming freshmen, students who need help to figure out the major works, transfer students. We truly appreciate the Wix officers, really the club and the CS club for the service they give to our department. And the next event is awards, distinction awards. And distinction awards, as you well know, go to those who, one, have GPAs of 3.0 and higher, and have served the department in some capacity, and have gone beyond the concepts that we teach in individual courses. And they pull together concepts in many courses. They really dive into the discipline as opposed to individual courses. It's my pleasure to present those awards. In general, the Computer Science Department has its lion's share of students who are on the Dean's list. If you ever walk by the Dean's office in that display case, just look at the number of computer science majors who are listed there. We really are proud of them all. And Jeffrey Bonds. Jordan Bergero. there. Grace and blanks. Brooke Borges. Lisa Churchman. Congratulations. Tyler Holland. Speaking of people who provide service to the department. Hanani Ike. Weston Mitchell. Rigoberto Moreno Delgado. Brittany Graham. She had injured her leg, that I know. Zachary Thurston. Chad Link. Fern Vu. Scott Williams. Lucas Winkelman.
Not a space.
Delete the last one.
Yeah, wait a minute, I need to get rid of some stuff.
So, courses. Have you been able to get into courses for next semester, those of you who are going to remain? We have a few issues, I know. 242 has a wait list. We're trying to work through that. 252 has a wait list. We hope to work through it. Unfortunately, 252 has this issue of, at least between the two, we have to put our money somewhere, and I'm really not sure at this point what we have as far as the faculty who are around and able to teach for us. So we're working on that.
Those of you who are graduating, contributions would be a really good idea.
As in human contribution.
Well, that too.
Yeah, we want your blood, sweat, and tears still.
As for of course, those who were awarded distinction are graduating, and we have a large class of students who graduated this semester, this and past semester, about 50 strong. That's an incredible number. It truly is an incredible number for a department. The department, of course, is pretty big. So for those of you who are graduating, we will want to get together with you after the commencement. So the idea right now is to gather in that courtyard just outside of Salazar Hall. And of course, this is, as you know, this time around, commencement is school-based, so our School of Science and Technology has its own time slot. But in spite of that, the numbers are such that I'm not sure if all of the graduates, or all of those who are going to attend, are going to fit into that courtyard. But do look for us. We want to get together and we want to take pictures. This time around, we usually have some reception for our graduates. Unfortunately, this time around, one, we're far away, and it seems like the parking on the campus that day is such that they have discouraged events on that day. So I just want you to know that we really are proud of you, and that we do want to get together there and to at least have some pictures. Now, we're of course out of disk space here.
No, we're not anymore.
But I do want to.
I want everybody who got distinction to come back.
Excellent. The distinction graduates. Please come
Yeah.
Yeah, can you scoot down so that you're in the middle, maybe in front of the screen? And taller people, and some of you, ones like me.
I think we need to.
Others, please join Lisa.
Be more friendly, be more friendly.
You get behind me.
Everybody in one room, in front of the screen. Okay,
Yes.
more of you.
First, let's take that.
So slide this way.
Close.
All right. Yeah. That's close as I'm gonna get.
Right?
Yes,
Okay,
yes.
good.
Okay, Ali, you can go ahead and join them.
Okay.
1, 2, 3, 4. Okay.
Thank you so much. Thank you, Dr. Watts. Okay, so as you perhaps do know, this is my last year of serving as the chair of Computer Science Department. So I started in 2010, and this is my last year, and in between what we've had was, we started at about 127 majors in 2010, and now we have 320 majors. And that's a staggering number. And I alluded to this, talking about the number of students that we have on the dean's list, and of course you see the number of graduates that we're going to have this semester. That's truly a growth that is unparalleled within that short amount of time within the university. Unfortunately, in spite of that, I don't think that our resources grew with the number of our majors. And guess what? You guys paid for it. And this is, I say you paid for it because we didn't have enough sections of courses, as much as we tried to accommodate everyone. You paid for it because the classes had too many students in it. And that's kind of another side effect. And more importantly, I think that unfortunately, the university stopped investing in academic departments at some point. And this trend is reversing with the incoming president kind of shifting the focus on the academics. So within this time bound that I just mentioned to you, what we gained as far as resources are concerned is the equivalent of one full-time faculty. Now, let me explain. We have two new faculty, Dr. Gill and Dr. Gundry. We're truly proud that we were able to attract them and that they are with us, so that makes two full-time faculty. And we will have one new faculty next year, so that's 3 faculty. But during the same time, Dr. Ledeen Ferb, so like Dr. Ledeen now is a half-time faculty, and that the new faculty do not carry a full load. So kind of putting all that together, kind of amounts to one full-time faculty. But nonetheless, so what that really has meant is putting a whole lot more work on the plates of faculty. And that you see, of course, again, you pay for it by not getting your projects graded, you being one of them. But nonetheless, I truly am proud of our department, and I mean it. It's a wonderful department, wonderful people, faculty working so hard to meet their obligations and beyond. And I am proud of it. I am proud for having been the privilege to serve this department and serve as its department chair. It's been an honor. I want to a round of applause for the faculty.
Yeah, so allegedly I'm going to be in charge in a second. So Dr. Kashesh promised he'd give me 2 seconds to speak about him, and I see that 2 seconds is exactly what I'm going to get. So, as he mentioned, right, when he took over in 2010, when Dr. Stauffer was elevated to being the dean of the entire School of Science and Tech, we had 120-ish majors, and now we're up to 350-ish. The research on what happens to departments during tech booms, and I lived through this myself as a college student, is not great, right? The lack of resources in response to the number of students coming in very often means that the only people who survive are people who've been programming since they were like fetuses. Community suffers, diversity suffers, there's hard data on this. And so I think it's very much to Dr. Kashesh's credit that we still have a thriving and diverse community in this department of people who came to us with all kinds of backgrounds and have been very successful. And he's done a number of things and marshaled a number of resources against all odds to make that happen. So as a token of our gratitude, we did some stuff. We have this very swanky plaque and this very swanky card and this little art project. So this is why you have to come take graduation pictures. These are pictures from your time as chair and all the wonderful things that have happened. So please join me in, giving our heartiest thanks to Dr. Kashesh.
I am grateful. I truly am. And I want to also say something about Dr. Rewar now that she's as you know, she's the next chair of the Computer Science Department. Dr. Rewar came here to SSU immediately after graduation from Stanford in 2008. And she was very young. One of the things that when she was hired we were concerned about was the speed with which she spoke. And we wondered if she could ever slow down to the speed of mortals so we can understand it. But definitely took that out of her, to some extent. Just listen to her when she talks and doesn't remember that she needs to slow her clock. It is truly, of course, department chairs get elected by all members of the department, and Dr. Ward had the confidence of every member of the department. I am truly grateful that she has accepted to follow, to serve as the chair of the department. That unfortunately is putting a person in an impossible task. Thank you, Dr. Rewar.
Of course.
We look forward to it. Thank you so much. Thank you for coming.